All right, good afternoon, everyone. On behalf of the National Glass Association, I'm Sarah Neiswanger, Associate Director of Industry Engagement. And thank you for joining us today for this Thirsty Thursday webinar featuring Thom Zaremba. Before we begin, please do take note of key NGA events coming up as they're shown on screen. And as I mentioned in the chat, please do use the Q&A feature in your Zoom toolbar if you have questions or comments along the way, and we'll regroup at the end to address items following the presentation itself. Registration is officially open for the NGA Glass Conference Milwaukee. High-performing glass is a theme here with VIG on display, both in the meeting room and at our offsite reception venue. In addition, you'll be treated to a virtual walking tour of iconic buildings in our host city, including an award-winning timber curtain wall project, a VIG installation, Milwaukee's tallest building, and a bird-friendly LEED Silver certified arena. Another reason to register today is that it's the last day to save $200 on your registration fee. Today is the early bird deadline and rates will go up starting tomorrow. So please do use the QR code on screen or type in that URL provided. If you know you're going to come, today's the day to save a little money on your planning. And Glass Build America is now nearly 3 months away. Registration for exhibit booth personnel opened this week. And for trade show attendees, your time to register comes July 16th. Be sure to plan your travel accordingly in order to stay for the Glass Build after party too. The magic of glass after party will capture the excitement of Orlando, our new host city for Glass Build 2025. This is meant for pure fun and networking to wind down after a productive show. A golf simulator and a virtual reality plank wall, plus snacks and drinks, of course, will be available. It's just $10 to add the magic of glass after party to your registration, and the proceeds benefit the NGA Foundation towards our efforts to increase industry education and resources. I'm now pleased to introduce Thom Zaremba. Thom's practice focuses on advising and representing clients in all aspects of the development of building codes and standards, including proceedings before the DOE, EPA, the International Code Council, National Fenestration Rating Council, National Fire Protection Association, ASHRAE, ANSI, the California Energy Commission, and numerous other forums. His clients include a number of worldwide glass manufacturers and trade associations representing the glass industry, including us at the NGA. Thom, welcome.
Sarah, thank you. And welcome everybody, all of you glass people out there. And any of you that know me know that I firmly believe one thing about glass, and that is that glass is magic. And today we're going to learn a little bit about one of glass's most and best magic tricks, and that is keeping people safe in a building fire and how and where that is done. So in order to give you an overview of what we're going to look at today, we're going to look at building compartmentation. And as a part of that, one of the most important parts, perhaps, of that, we're going to look at what is known as a building's means of egress. We're going to see that it has every building's means of egress has 3 component parts: an exit access, the exit itself, and the exit discharge. Then we're going to see one of the most important features in the means of egress where glass, fire-rated glass specifically, is used. And that is in egress doors. So, why compartmentation? There are 2 types of fire protection in a building. One is active, and that usually consists of sprinkler systems. The other is passive. And what that means is that in a certain area of a building,
which is compartmentalized from the others in the event of a fire, the materials used to build that compartmentation are fire rated for a specific period of time. Sometimes an hour, sometimes an hour and a half, sometimes 2 or longer hours, depending on usually the height of the building and the type of means of egress that building has. So let's just jump right into compartmentation. And if Sarah, if you could move to the next slide and start the video. I'd like you to watch this. This is a real fire. It's one recently. It's an apartment building, and it's a garage fire. A number of cars were engulfed by flames, exacerbating the fire as they were engulfed. Take a good look. That is what I would consider to be a horrific fire. Interestingly, because of compartmentation and a rapid fire service response, the fire was put under control, brought under control, and the apartments above the garage were undamaged. The people were able to get out of the building despite the fire. And you can see in one of the testimonials on the left-hand side of your screen, one of the people in the fire said, I just woke up to the sound of crackling and a scream, and I looked out my window and saw red. I grabbed my cat, woke everybody up, and got out and looked. My car was on fire. They got out safely. So if you could go to the next slide, Sarah, I'd appreciate it. The first question is, would sprinklers in this garage have prevented this? Well, the fact is that sprinklers go off one at a time depending on the heat around the sprinkler head. If the heat reaches a certain point, the sprinkler goes off and creates a dome-shaped fire, spread of water that is not meant to put the fire out. It's simply meant to be enough water to equalize the energy so that the fire doesn't continue to spread. It maintains control of the fire, not putting it out usually, until the fire service arrives and can put the fire out. A number of things, including accelerants and flammables, can overwhelm a sprinkler system even if it's there. What that means is that even if this garage had sprinklers in it, they very well could have been overwhelmed by the fuel loads in these vehicles that caught fire. So why were the building occupants able to get out? Well, that's the means of egress. And if you could go to the next slide, Sarah. The IBC defines a means of egress as a continuous and unobstructed path of vertical and horizontal egress travel from any occupied portion of a building or structure to a public way. And this is one of the important things. A means of egress consists of 3 separate and distinct parts: the exit access, the exit, and the exit discharge. So let's talk about the first one, exit access. That is also defined in the code as that portion of the means of egress system that leads from an occupied portion of an occupied building or structure to an exit. Arguably, the means of egress is one of the most important features of the exit access, rather, is one of the most important features of the means of egress. Where is it? Well, if you're in a building that has an open floor plan, for example, one without corridors or hallways separating offices and so forth, there really is no discernible means of egress, because in an open floor setting, the exit access is look around, you find an exit sign, That's where the exit part of the means of egress system is. And any path that will get you there is your exit access. So if the building is not an open floor plan and instead has corridors separating office spaces and tenant spaces and so forth, the corridor will be your exit access. And you get into a corridor in a building like that and look in both directions, and you will find the exit sign, which is the opening to the exit portion of the means of egress. So they're elusive, these exit accesses, because you can't always figure out where exactly they are in the building. And likewise, they're not usually protected. And if you could go to the next slide, Sarah, I'd appreciate it. You'll see in this table that only some corridors have a fire resistance rating. The rest are unprotected except for, in some cases, a sprinkler system. For example, in an E occupancy, the third box down, which is educational occupancies, if the occupant load is greater than 30, and if there is a fire sprinkler system in that school, the corridors between classrooms leading in and out of classrooms has a 0 rating. That means it is unprotected. Things that do have protected corridors are several residential or R occupancies and I occupancies, which are hospitals and some prisons. They are institution occupancies. So as you can see, most occupancies have 0 protection in the exit access corridors. Next slide, please. What is protected is the exit. Definition of an exit is that portion of the means of egress system between the exit access and the exit discharge or public way. Exit components include exterior exit doors at the level of exit discharge, interior exit stairways and ramps, exit passageways, exterior exit stairways and ramps and horizontal exits. I want you to note that the horizontal exits that is being talked about in this exit means of egress system are not to be confused with horizontal assemblies, which is another defined term in the code. The latter, which are horizontal assemblies, are actually fire-resistant rated floors or ceilings. The horizontal exit is a refuge area constructed of fire-resistant rated materials, usually in buildings where people are expected to be unable to use the building's egress system. For example, an inability to use stairways at some hospitals where invalids, or sections of hospitals where invalids were bedridden or unable to maneuver the stairway system that might be in that institution. Exits are fully protected areas of a building and are constructed such that they will prevent the passage of heat, temperature rise that is, fire, flames, hot gases for usually an hour and a half to 2 hours. And that is what permitted the tenants in that building that you saw that was on fire in the garage to safely escape the building. And also the compartmentation of a horizontal assembly in the roof of the garage protected the apartments from the fire raging below in the garage of the automobiles that caught on fire. You go to the next slide, please.
Yeah. Tom, I did want to just take a moment. There seems to be some audio challenges in how we're able to hear you, similar to what we experienced before signing on. I didn't know if there was a position we could attempt to change real quick as we move on.
Changing a position. I have a laptop, so I'm obviously using that. Is that better, Sarah?
Yes, this sounds much better now. Thank you.
Okay, I've also reduced the volume, so perhaps that is helpful.
Great. Okay, I added one more line to the existing slide.
Thank you. So again, there were three parts to the means of egress system: the exit access. It's also the exit system, which is the protected portion, and finally the exit discharge, which is the portion of the means of egress system between the termination of the exit and the public way. So those are the three primary components of the means of egress system in a commercial building. And if you could go to the next slide, I'd appreciate it. And here we're going to address, again, what is a very important component of the means of egress system insofar as fire-rated glass is concerned, and that is the egress doors. First of all, what are they? Egress doors are the doors used by building occupants to enter the means of egress. They include doors from any occupied portion of a building into either an exit access corridor or into an exit itself. And as you may recall, the definition of a means of egress system was a continuous and uninterrupted system by which you exit a building in the event of a fire. And it's important to understand that the door cannot become an impediment. Next slide, please. So here's a diagram of what in a building with corridors between perhaps office buildings and conference rooms, and all of the egress doors that would be involved in that, leading from offices into the corridor, are egress doors, and those have to be fire rated if the corridor is required to be fire rated. And we talked about that and the table that it was associated with it. And one of the important features is that all egress doors must be swinging type doors. That is side hinged, pivoted, or balanced doors. And that's in IBC Chapter 10, the Means of Egress Chapter, Section 1010.1.2. If you could go to the next slide. There are exceptions to the requirement that egress doors be swinging. And you can
Tom?
see quite a few of them. Can you still hear me, Sarah? Is it any better?
It's back to better. Yes, thank you.
Okay. And perhaps one of the most critical exceptions is number 6. And in occupancy groups other than high risk, special purpose horizontal sliding accordion or folding door assemblies that comply with a number of requirements specified in 1010.33 are permitted. And why is that important? Well, usually these sliding doors are electronically operated. They have sensors that perceive someone approaching and they slide open and closed. They also have to be operable without power and have backup power and so on and so forth. But if those are egress doors in a corridor that is required to be fire rated, or a door entering into an exit from an exit access, they can be fire rated glass. And that is in large measure the importance of exception number 6 to the requirement in 1010.1.2 that egress doors be swinging style doors. Next slide, please. One of the requirements for these glass doors, any glass door, whether it's a swinging glass door or a sliding glass door in an egress, that is an egress door, is that first of all, the glazing in it would have to be listed and labeled. And depending on whether or not it is fire protection rated or fire resistance rated glazing, it would either have to be tested to NFPA 252 or its sister standard 10LB, UL's 10LB, 10B rather, I'm sorry. And these are usually going to be in applications an hour and a half or less where fire protection rated glass will be permissible. Or the glazing in the door has to be tested to ASTME 113, which is the fire resistance rating test, and to the door test of NFPA 252 or 10B. Usually you're going to find fire resistance rated glazing in applications of an hour and a half or higher. Again, in most applications where the fire resistance rating of the associated wall is an hour and a half or less, the glazing in the fire door would be permitted in the maximum size tested if it's fire resistance rated. If the application is 1.5 hours or less, the size of the fire protection rated glazing, greater than an hour and a half, the size of the fire protection rated glazing would be limited to 100 square inches. If it's an hour and a half, the fire resistance rated glazing would be permitted in the maximum size that is tested. So that is the means of egress system, compartmentation, and egress doors, where much of the fire rated glazing in the compartmentation and means of egress system of the building are located. And Sarah, with that, we can take some questions.
Okay, excellent. We do have a few that have come into the Q&A, so I'll start with those. And then we did receive a few from folks in advance who, read the email and submitted some questions for consideration. So we'll move on to those and then see how we're doing on time. So first question, are horizontal assemblies, floors and ceilings, always fire resistance rated?
Well, yes. The answer is yes. And again, the horizontal assembly fire resistance rating is intended to protect occupants above the fire or below the fire, depending on whether you're above or below it. And yes, typically there is a fire resistance rating attached to them.
Okay, great. Why would glazing and egress doors not have to be limited to just the glazing? It should be the entire assembly, door and frame, not just the glass and the individual components.
Could you repeat the first part of that question, Sarah?
Simply, why would glazing and egress doors not have to be limited to just the glazing versus the entire assembly?
Well, actually, the testing of a fire door is done as an assembly. So it would include the framing, the hardware, the glazing, if any, that is in it, and it would all be tested in the fire, whether it's an ASTME 119 test or a fire door test using NFPA 252. But yes, the entire assembly, not just the glass, would have to be tested.
Okay. Would a walkable skylight need to meet fire resistance ratings?
It's a good question. I don't think typically they would require a fire resistance or a fire protection rating.
You don't think they would, you said?
No, I do not believe that skylights require a fire protection or a fire resistance rating if they're walkable, unless perhaps the roof that they're in was occupiable. If it was an occupiable roof with a walkable skylight, that may well require the fire resistance rating of a horizontal assembly.
Okay.
And as you probably know, there are more and more occupiable roof being built today than in the past. So that's a good question.
Mhm. Have you seen at perimeter curtain walls that exterior glazing above a 2-hour horizontal assembly is usually rated glazing to prevent flame spread outdoors from one floor to the next?
Typically, the joints are fire protected, but leapfrog effect typically is protected through protecting the joints between the building and the floor, not by virtue of the glazing in the floor above it. In most buildings, however, if you are within a certain number of feet from the property line, the exterior wall, or at least part of it, would be required to be fire resistance rated in order to avoid horizontal fire spread from one building to another. Those types of applications are relatively unique in the code in that glazing used in exterior walls that require a fire resistance rating to avoid horizontal fire spread typically only require testing from one side. They do not require fire testing on both sides. And the side that is tested, has to be tested, is the interior side of the glazing. You can certainly test both sides, but asymmetrical testing is not required if the application for that fire resistance or fire protection rated glass is in an exterior wall. Again, that's very unique insofar as the International Building Code is concerned.
Okay, great. What is the criteria to distinguish a window from a wall when deciding the fire resistance criteria?
A fire window is one which does not include the entire wall. For example, you have a door with a transom above it and two side lights, one on each side of the door. The side lights are and the transom are considered to be part of the fire door assembly, but they are tested both to the fire door test and to the fire window test, NFPA 257, if it's fire protection rated glass. So windows are an opening in a wall. A glass wall is the entire wall. A glass wall would have to be in a means of egress system, would have to be fire resistance rated and tested to ASTM E119. If the glass is in a window or in a side light or a transom, you could have fire resistance rated glass, depending on how long the fire door has to be tested for. It probably would be permitted in unlimited size or to the maximum size tested. So an opening protective is a door or a window in a wall. It's an opening in a wall or a opening. Both the window and the door are openings in a wall. The wall itself is a fire resistance rated product. Hope that answers the question. Opening protectives are dealt with in Chapter 7 of the International Building Code. They're called opening protectives because they are windows and doors that are openings in fire resistance rated walls. Next question, Sarah.
Yeah, what type of non-insulated glass meets the fire resistance rating? In any coated or specialty glasses included there?
The question is non,
What type of non-insulating glass meets the fire resistance rating
well,
in terms of
there-
coated or specialty glass?
there are lots of fire resistance rated glazings that are not insulated glass. Double glazed is what I assume is the question means. And that includes ceramic, wire glass, and intumescent products that are fire resistance rated. So all of those types would typically be used indoors in a non-insulated or non-double glazed assembly. Next question.
Okay. Does the glass fabricator or the door manufacturer, sorry, let me rephrase, is the glass fabricator or the door manufacturer required to submit for testing?
Okay, I don't quite understand the question. What, could you repeat it?
Does the glass fabricator or the door manufacturer need to submit anything for testing?
Well, if a fabricator or a door manufacturer are manufacturing doors for use as egress doors or fire rated doors, they would have to be listed and labeled, and to be listed and labeled, they would have to be tested. Excuse me.
And are the specific standards for glass certification listed in NFPA 252? IBC 1010?
I'm sorry, what was the question again?
Are the specific standards for glass certification listed in NFPA 252?
The acceptance criteria for the testing of fire protection rated doors in NFPA 252 are certainly listed. If that is the same concept as the question is suggesting as certification, the answer is yes. If they're different, I'm not quite sure I understand exactly what certification requirements would mean in that context.
Okay. Well, we can come back to that if needed.
Okay.
We still have 3 or 4 more questions, more coming in yet. If standard, I apologize, I don't know the acronym. If standard HM framing is ultimately being used in a 60-minute fire rated application, including protective only glazing, what would allow that? My understanding is that a 60-minute or above, the whole assembly needs to be resistive per Chapter 7 of IBC 2015.
Well, I can say generally that if it's over an hour and a half fire rating, let's back up. Typically, the protective or fire resistance rating of a door or window depends on the wall into which the door or window is being put. So if the fire resistance rating of the wall is an hour and a half or greater, usually greater, then typically the glass would be required to have a rating which is fire resistance rated. If, on the other hand, the fire resistance rating of the wall is an hour and a half or less, typically the door, especially the door, would very likely have a fire rating less than that of the wall, it probably would permit the use of a fire protection rated glass in some size, whether it's 100 square inches or larger. And it would certainly permit the use of fire resistance rated glass generally in the maximum size tested. I hope that answers the question.
Okay. Are there any statistics on the efficiency of sprinkler systems?
Yes, there are many statistics. The last ones, and they're published typically by the National Fire Protection Association. And typically sprinklers have a 90% effective control of fire rate. So that if there's a fire, in 90% of the cases statistically, the sprinklers will operate to contain the fire until fire service members arrive and are able to put the fire out. In some 10%, not so much. And it's in those 10% that you better start looking for the exit access pretty quickly and get into that protected area of the exit part of the means of egress system as quickly as you can. Because in an unprotected exit access, you're on your own to get there safely. There will be no protection except for the sprinklers. And in that 10% of the cases, they didn't operate. So I hope that answers that question. Another one, Sarah?
Yeah. Are there clear guidelines on when traditional wired glass can be used in doors and frames versus when ceramic glass is required?
Yeah, there is. You have to remember that wired glass is typically 3/4 to an hour fire rated. And it is permissible in any non-hazardous location. That means, for example, if you have a door with a transom above it, and the door and frame and transom all have to be fire rated, and it's in a, for example, a corridor. Corridors in exit access systems typically have a 1 hour fire partition requirement or a 1 hour fire resistance rating. In a 1 hour fire resistance rated corridor, typically you can use fire protection rated glass that is tested to last for 3/4 of 1 hour. Typically, wired glass will comply with that from a fire standpoint. If it's in the transom above the door, it's perfectly permissible to use wired glass. If it, however, appears in the door itself, or if it is in a transom around the door, or if it's in a window opening in the corridor, and that window is in a human impact location, then the wired glass would have to carry with it a monolithic, an organic film in order to protect it from human impact. There are films, organic films, that can survive the fire test and also provide protection under ANSI Z97 or 16 CFR 1201, the human impact standards. So in those applications, you can use either ceramic or wired. If it exceeds the hour limitation that generally wired glass is able to survive in a fire, then it would have to be a ceramic glazing, because ceramic glazing certainly will survive fires for 1, 2, 3 hours. They also have to have an organic coating if it is in a hazardous human impact location.
Okay. On the topic of films, we have a couple about that. Does adding a safety film to wired glass void the fire rating of the wired glass?
It depends on the manufacturer and it depends on the one doing the filming. Certainly post installation filming doesn't comply with ANSI Z97 human impact requirements. But if it is a manufacturer applied film, if it is a fabricator and applied film, it may well be covered in the terms of the warranty because the manufacturer is doing the application and is testing the product as a fire-related product with that filming. The application of a non-fire rated film, in other words, one that actually flames in a fire test, that's going to probably void the warranty on the product.
Okay, and when installing fire rated glass with a film, does the film go on the exterior or interior side?
It depends on how it's tested from Z97. It could go on either, and it may well pass the Z97 test. Typically, again, unless it's an exterior wall application, that fire testing has to be asymmetrical, which means it has to be fire tested on both sides, not just one side.
All right. If a water curtain is installed on the inside of the building, does the glass and aluminum have to be fire rated?
Excuse me, what was the last part?
Does the glass and aluminum have to be fire rated?
There is an ICCES, which is the International Code Council Environment. ES is the evaluation services subsidiary of the International Code Council, and it has issued a very specific criteria that a deluge system, sprinkler system, must meet in order to eliminate a fire protection rating for an associated glass. And typically, not in every case, but typically, the use of that ICCES criteria to eliminate fire rating of a glazing material in a fire resistance rated application would require permission of the building code official in terms of a variance from the fire resistance rated requirement. So it isn't that it can't be done, it's that there are a number of specific limitations on the use of those types of sprinklers in order to reduce building code required fire resistance or fire protection ratings.
Okay, great. Now shifting to energy performance. How can fire rated window producers give feedback to ICC and regulatory authorities regarding energy performance of life safety fire rated windows to inform performance requirements?
I'm glad you asked that question. That's a very good question. It's one that I've asked and one that I've had answered on a number of separate occasions by fire rated fabricators and fire resistant and fire rated glazing manufacturers. And that is that from an NGA standpoint, membership in the Glazing Industry Code Committee at NGA will always entitle your voice to be heard as to any interrelated energy code, and fire code or building code relationship or application. And if there is a difficulty on the part of a fabricator or manufacturer of fire-rated products to comply with both fire and energy code requirements, those concerns should be expressed through membership in the Glazing Industry Code Committee to the code consultants. Typically, Tom Culp represents the National Glass Association in energy matters, and I and Nick Resitar represent the National Glass Association in fire protection rating issues. But we both, all of us, work together hand in hand in making sure that energy code and building code issues are brought to the attention of the GICC membership or the Glazing Industry Code Committee membership, and that their input is taken back to the building code authorities that are developing those codes. In the past, I have asked specifically the question whether any of the energy code requirements interpose a problem in the fabrication of fire-rated windows and doors, particularly in exterior wall applications where both building code, fire code, and fire code regulations are in place, but so are energy code requirements. And so far I've heard that yes, fire-rated fabrication manufacturers can indeed meet both requirements in a various numbers of ways and in techniques that they use. Some, for example, might include the inclusion of a sacrificial double glazed energy efficient unit attached to the fire rated product in order to meet both fire rated requirements and energy code requirements, or other methodologies can be used. But so far, from a Glazing Industry Code Committee standpoint, we have not encountered any significant impediment to compliance with both energy and fire code regulations. If there are concerns, my advice would be to anyone in a company in the listening audience is to join membership in the Glazing Industry Code Committee to absolutely, every time there's a change in the code, whether it's a fire-related change or an energy code-related change, you can have your voice heard.
Okay, great. Tom, before we move on to, I think we have time for 2 more questions. We've received many more than that, so I apologize if we don't get to yours, and we will make sure to follow up with you by email if that's the case. But Tom, one question, are you open to sharing your email address if somebody wanted to reach out to you with a specific question?
Sure, recognizing that I typically don't deal with any specific application in the field. And the reason for that is that it exceeds significantly the knowledge of model building codes and gets into the issue of the jurisdiction's edition of a building code or a fire code. What edition is it? And every question that is actually related to a field application is simply too specific for me to get involved with. So yeah, you can share my email address, but understand that if I am asked a question concerning any specific application in the field, I either won't accept the question, or if I do, you would have to engage a retention agreement with my firm in order for me to research and resolve that specific question. Okay?
Okay, great, thank you. I will put your email in the webinar chat
Sure.
for folks to grab if they like. So one question, generally speaking, have you seen any interpretations that might lead to a side light being rated differently than the glass in a door itself, even though it's part of the same building component?
No, the building code actually defines the door assembly to include anything in the door frame. So if the door and the side light are in the same frame structure, it will have the same rating. If, however, the side light is actually a separately framed assembly from the door assembly, it could have a potentially a different rating, although frankly, that's fairly unlikely. Although, no, excuse me, I take that back. That is not necessarily unlikely. It is very possible that it could have a different rating. And the reason is this, is that the fire loads attributable to a door take into consideration the fact that you have to get through the doorway. In order to get through the doorway when it's open, you can't have fire loads stacked in front of the door itself. That would block your pathway through the door. As a result of that reduction, recognized reduction in fire load in front of the door, it could have a reduced fire protection, fire rating than, for example, a window right next to it, which could have flammables stacked right below it and have therefore a higher fire rating. So fire doors can have a reduced different fire rating than side lights. The typical example of that is the 20-minute fire rated door, which requires 45-minute rated side lights. Okay.
Okay. Let's see. For residential single dwelling homes with attached garages, is the wall from garage to house fire rated? And also, if so, what would the rating be if someone was looking to install a large window from kitchen to garage?
What was the first part of the question? Is what rated? Fire rated?
For homes with attached garages, is the wall from garage to house fire rated?
Yes, typically it has to be fire rated because of the fuel loads in the vehicles. And whatever the fire resistance rating of the wall separating the garage, the attached garage from the dwelling portion of the unit is, that would also govern typically the fire protection or fire resistance rating of the window from a kitchen to a garage. Although not really sure why you'd want to look from your kitchen into your garage, but I guess you might want to. And if you did, you'd have to have the same rating as the fire rated wall.
Okay, great. Well, I think with that, we're coming up at the top of the hour, so we'll need to hit pause on the rest of the questions. But as I mentioned, we will do our best to follow up with you by email if we didn't get to it. Thom, thank you very much for your presentation and also just excellently addressing all of the questions that have come in. There's obviously a lot to discuss here.
It was great fun. Thank you.
Mm-hmm. We do have, for those on the call, if you haven't checked out, it's an NGA member only benefit, but it's our Codes and Standards Help Center. I will put that in that link in the chat. This does take you to a variety of topics related to fire rated glazing. There was a question we received about their proximity to a wood or timber building. And this does address tall wood buildings in relation to fire rated glazing. So I encourage you to check that out. If you're not a member, please get in touch with me and I'd be happy to discuss that more with you as well. And please do mark your calendars for July 11th for our next Thirsty Thursday. This is a window and door fenestration focused presentation covering some market data and survey results from the past quarter. Thank you again and have a great afternoon. We'll see you next time.